Welcome to the Rocket Warhead Demating Machine, also known as RWDM. In collaboration with the Bluegrass Chemical Agent Destruction Pilot Plant, the Program Executive Office, Assembled Chemical Weapons Alternatives, the United States Department of Defense, Amentum, CRG Automation, and others, we have come together as one team with one mission, our final mission.
Today we're conducting what we call the factory acceptance test for a system that's known as the Rocket Warhead Demating Machine. This process has been designed to be able to potentially address the most challenging of the GB rockets that exist in the stockpile at Bluegrass Army Depot. We know that there are certain munition lots that contain agent gels that may not be appropriate or may be difficult to process in the main plant, and they would be deliberately sent to this equipment for processing.
The timeline of this one, really 3 months, not only to prepare all the equipment that we're seeing in the video today, but to go get an earth-covered magazine outfitted and prepared to meet this same deadline, and that both jobs finished the same week so that we can bring everything together. That truly tells you we're in sync in the collaboration that goes on there. And again, a lot of credit goes back to the direction we received from Aqua, the customer.
I think this is one of, for me personally, it's been one of the best projects that I've ever worked with. The amount of teamwork and the collaboration between the government and our OTA contractors, Amentum, also with BG Cap's joint venture, Bechtel Parsons, and of course, obviously CRG. It's just been, it's something I've never seen before. And to see the collaboration, the teamwork is really good to see.
To begin operation, the system must be preloaded with 3 rocket warhead containerization system skids, 2 rocket mortar crates, 2 upper shipping and firing tube containers, and 15 M55 rockets. Each is to be transferred into the earth-covered magazine and its various locations as designated using a walkie stacker fork truck. The RWDM system will utilize the same Rocket Warhead Containerization System, or RWCS, skid that is currently in use in the main plant with a holding capacity of 25 canisters. One skid will have 25 empty canisters, the second skid, 5 empty canisters, and the final skid completely empty. The RWCS stations will have magnetic pullers and pneumatic pushers to locate the skids consistently for robot operation. 4 pallets of M55 rockets will be brought into the unpack area to begin the process. This will allow a total of 60 rockets to be processed. The forklift operator places an M55 rocket pallet on the adjustable height unloading table. The operator will then mark the shipping and firing tubes, or SFTs, at the 12 o'clock position to maintain storage orientation. 2 operators will then load the rocket non-destructive examination input carousel cradle. Utilizing 2 sets of indexing control stations, 1 on each end of the carousel, each operator will press the button on their end to index the carousel to the next open position. The operators will then repeat this process until 15 shipping and firing tubes are placed in the carousel.
Rock the rocket back and forth and load cradles to ensure both ends move freely.
Part of the objective of this project was to bring in at least 15 of these rockets at a time and automatically process them through from the beginning to end. And we came up with a very unique way of allowing the operators to enter the bunker, manually load a carousel sort of design with the rockets, and they would leave the bunker. And when we started the system, the carousel would feed and automatically x-ray the rockets for any leakage. They would transmit them or transfer them down the conveyors to the processing station where they would be cut apart, disassembled, and repackaged. So some very unique and challenging designs we had to come up with in order to not only handle all this automatically, but fit it into an earth-covered bunker.
Once the input carousel has been loaded and the unpack area operators have left the room, the control room operator can start the scanning process via the Human Machine Interface, or HMI. Once the HMI commands have been given, the 2-axis robot will pick up a shipping and firing tube from the carousel and place it into the X-ray cabinet and close the top door. The X-ray motion sled translates over to the scanning zone and tilts the SFT 10 degrees down to allow for easier liquid detection in the M56 Warhead. Once the X-ray scan is complete, a trained operator will be presented with an image of the results to interpret on the HMI. Based on the operator's assessment, an accept, retry scan, or reject designation will be manually input into the HMI. All image acquisition and reviews will be done in the image review and disposition system in the control room.
Liquid, and also examining the shipping and firing tube area.
Before you cut into these things, understanding that what's supposed to be in the places that it's supposed to be is paramount to success. And the X-ray allows you to see that entire process. We use a process called a LARA, as low as reasonably achievable with our radiation boundaries. And this system was designed to deliver 0 radiation, and it did. So there's absolutely no areas with the redundancy of interlocks that you can have a failure that could cause somebody to have a safety moment with radiation. The image quality was greater than what we expected. That's always a good thing. And we've seen the results of some of the imaging that we've had from the first R&D system, and we've picked up and identified things that I didn't even know that we could do. So it's been a great success.
The shipping and firing tube will then be conveyed from the rocket non-destructive examination system into the Alpha airlock. The rocket material handling gate nearest to the unpack area will then close. The rocket material handling airlock gate nearest to the process area will then open to allow the conveyor to move the shipping and firing tube from the Alpha airlock into the process area. The shipping and firing tube will then be conveyed to the end of the conveyor. The last section of conveyor is mounted to the horizontal slides that will traverse the conveyor section into the rocket handling robot's reach area. From here, the SFT will be placed into the vertical rocket cutting machine, which is the same design as those currently in use in the main plant. Once the SFT has been loaded and is securely held by the lower clamp, the cutter assembly will engage and the cutter wheel and back rollers will be driven inward to the start cut position. The cutter assembly rotates 370 degrees, alternating back and forward bidirectionally around the statically held shipping and firing tube. The top half of the shipping and firing tube is then removed and placed on the transfer station. The robot then grips the exposed warhead with the end of arm tool, and the rotating cutoff tool separates the warhead from the rocket motor. The robot will then move the upper shipping and firing tube from the transfer station and place it into the upper shipping and firing tube container. The robot will then pick up any empty canister from the canister transfer and weigh station and place it into the crimp station. The crimp station will lower the canister, and the lower gripper on the crimp station will securely grip and hold the canister. The robot will then remove the top cap from the canister and place it onto the canister cap holding station. The robot will then pick up the cut warhead from the warhead and shipping and firing tube transfer station and place it into the canister. Then the robot will pick the top cap from the canister cap holding station and place it back into the canister containing the cut warhead. The canister will then be crimped. After crimping, the crimp station will raise the canister up to be picked by the robot. The robot will then place the canister onto the scale of the canister transfer and weigh station. The weight of the canister will be recorded by the historian. After the weight is recorded, the robot will remove the canister and place it into an empty opening on the RWCS skid. This will repeat until 15 rockets have been processed. Then, a brief entry into the unpack area to support reloading the rocket non-destructive examination carousel with 15 more shipping and firing tubes. Once 30 rockets have been processed, a full changeover of all skids and containers will happen.
The whole purpose of this contingency is to increase our safety margin at the plant and be able to give us an avenue to handle some of the lots of rockets that are gelled and crystalline and are not the best candidates for main plant.
As you can tell, I've been in this business a good while, and this is the best team that I've worked with. Couldn't ask for a better way to end my career. This is that time, you know, and working with these folks, just everyone worked together, delivered an amazing short time frame, a solution that we all desired to provide.
I've been working in chemical weapons disposal since 1986. And one of my things is, how do you want to be remembered? I believe I can say I'm going to go out on the top of our career and the top of completing the mission for Aqua and doing so in a manner that is very professional.
It's been fun. And honestly, I'm totally serious. This has been probably one of the best projects I've worked on throughout my career, you know, with the government.
This is a fast and furious project to procure equipment with the supply chain challenges that there are. We had a very short timeline to assemble this to meet the government client's need. The supply chain was one of our biggest challenges. Fortunately, we had the Defense Procurement Act. We utilized that to put our needs above other customers' needs. And the vendors that supported us on that were like, oh, you're destroying chemical weapons. How can we help you? The other aha moment, I would say, is the participation and support that we had from our government client and from our operations folks, having personnel, boots on the ground, running, operating equipment, assisting, seeing how it was assembled, so they can maintain it and operate it better once it's installed at the facility.
CRG Automation is humbled to have worked with such an incredible and collaborative team over the last 4 years. Congratulations to all who have been involved. Mission complete.